start. Ready, set, let's go. Trigonometry, bro. I know you know. I go psycho when I see a triangle. Just can't sit. Gotta get tricky with it. That's it. 3 angles, 3 sides. T-R-I-G. All up in my eye.
Trigonometry. Alright, ladies and gents, we are going to get started on one of the most exciting topics to me in geometry, which is a special unit that includes trigonometry. So in trigonometry, I'm going to give you just a few basics on what trigonometry means, like the definition, and when you can use it. So trigonometry is a branch of math that only can be used with right triangles. So the only time we're going to use this, and that's why this unit is called right triangles, is if we have a right triangle. And what we can do is we can find missing sides and angles. So we can look to find if there is missing sides or angles. And how we do that is we're going to set up a proportion or a ratio. So we're going to set up ratios and proportions to do so. And so just to remind ourselves real quick, I'm going to draw a right triangle and remember the parts of what a right triangle is. So the most important part, well, I guess not the most important, but a really big part that we need to remember is this piece right here, which is called the hypotenuse. And then the other parts are the two legs. So you want to remember that, keep in mind, especially the hypotenuse, because we're definitely going to use that in a second when I explain the ratios and proportions. So what we're going to do now is learn 3 different equations that deal with finding missing sides and angles in the trig functions. Alright, here we go. So in trigonometry there are 3 functions, and I know you've seen them on your calculator before, and those functions are 3 functions called cosine, and that's the real life specific name, the sine, and the tangent. And whenever you're talking about these functions, you are referring to an angle. So you would be referring to like the cosine of angle x or the cosine of angle y. So whatever it is that you're talking about refers to an angle. So I'm putting a little x with a degree so you know that each of the functions is always paired with an angle. Then, just to show you as well on the calculator what this means. So on the calculator it's going to be a little bit different because the calculator abbreviates this. So just to show you what the calculator would write, it would be the cos of x, the sine of x, and the tan of x. Alright, each of these then are related to a ratio of the sides. So what we'll do is make that ratio. So the ratio is equal to, for a cosine of x, the adjacent angle, or sorry, adjacent side over the hypotenuse. So it's the adjacent over the hypotenuse. The sine of x is equal to the opposite side over the hypotenuse. And the tangent of x is equal to the opposite side over the adjacent side. Now I know right now you're looking at this and like, what the heck are you talking about? I have no clue what's going on, and that's okay. Just know that right here, these formulas do need to be memorized, and it's really going to help you on the ACT because I know you saw a bunch of questions with these letters, and I guarantee that they were going to ask you to set up some ratios. So I'm going to show you what those ratios look like. We're going to look at 2 examples, and then I'm going to show you an acronym that will help you to memorize this for your ACT or your test. Alright, let's look at the first example. So the first example, we're going to draw a triangle here, and I'm going to label the sides as 5, 12, and 13. Here's my right angle. And so, like I said, whenever you're talking about the trig functions, it has to be in relationship to an angle. So I'm going to put this angle down here at the bottom as angle x. So what I do whenever I know what angle I'm talking about, I always circle it as my point of reference. So we are going to find the cosine of x, the sine of x, and the tangent of x. And remember, each of those are a ratio. So these numbers over here, the 5, 12, and 13, we're going to put them into fractions according to their formulas. So if you remember, the cosine of x was equal to the adjacent, I'm going to abbreviate, over the hypotenuse. The sine of x was equal to the opposite over hypotenuse. And the tangent was equal to the opposite over adjacent. Now, what does that mean? Like, well, how do you know what's adjacent, what's the hypotenuse? So let's look at the triangle, and remember, we're looking at x. So in this picture, there is only one hypotenuse, and hopefully you're saying to yourself, that's 13. So I'm going to go ahead and label the 13 as my h, which means that's my hypotenuse. Then we have to figure out, what does the 5 and the 12 mean? I'm going to go with the adjacent one next. Do you remember what adjacent means, like adjacent angles? Well, that means that they're right next to each other. So what side is directly next to the x? The 12 is right next to the x, like, touching it. So the 12 is going to be considered the adjacent side to the angle x. The hypotenuse is also adjacent, but it's the hypotenuse, so it can't be the adjacent one. So what does that leave my 5 to be? Well, the 5 is going to be the opposite, because the 5 doesn't touch the x degree whatsoever. So 5 is going to be represented as the O. So now that you have these labeled, you can go ahead and make your fractions. So the cosine of x is going to be the adjacent side, which is 12, over the hypotenuse, which is 13. So that is your ratio, or your fraction of the cosine. The sine of x is going to be the opposite number, which is 5, over the hypotenuse of 13. And the tangent is going to be the opposite side of 5 over the adjacent of 12. And so there you have it. That's how you set up your ratios for the 3 different trig functions looking at a triangle. So what we're going to do is we're going to try one more time with the same triangle, and we're going to move the degree. So let's do this one more time, and we're going to try the same thing, but we're going to switch the degree like I said. So keep 5, 12, and 13, your right angle, and this time, instead of the x in the bottom right corner, I'm going to make a different variable, because it can be anything. I'm going to make this angle W. So we're going to find all the ratios for the angle W. So I'm going to go ahead and circle that. I just like to get in a habit of it, because I know then that that's what I'm looking for, and that's my point of reference. So I'm going to set this up again. I'm going to look for the cosine of W, the sine of W, and the tangent of W. And I'm going to go ahead and write the ratios. The more you write the ratios, you're going to memorize a lot easier. So cosine is equal to adjacent over hypotenuse. Sine is equal to opposite over hypotenuse. And the tangent is equal to opposite over adjacent. So in our picture, let's start with the hypotenuse. That's the easiest one. 13. Never going to change. Always going to be the hypotenuse. It's the longest one. So that is H. Let's go to the adjacent one then. Which one is adjacent this time? This side right here is right next to the W. 13 is the hypotenuse, so 5 is going to be the adjacent one this time. So see how it switched from the last triangle? Because we changed where the angle is. So now the adjacent and the opposite also change. So this time the 12 is going to be opposite of W because it's not touching it. So now we can go ahead and set up the fractions. So the cosine of W is adjacent, which is 5, over hypotenuse 13. The sine is opposite of 12 over hypotenuse 13. And then the tangent is going to be opposite of 12 over adjacent of 5. So we'll go through some more, like I said, lots of examples. We'll see lots of different ways how they're related. But let me show you real quick an acronym for you to memorize this. So you don't have to write this part down again. You already have this part right here, all these equations. What I would write down is this right here, SOHCAHTOA. Kind of sounds like Native American, like a, Indian name or something, SOHCAHTOA. But if you can remember SOHCAHTOA, let me show you how it works. So the SO represents, the S is sine, equals opposite over hypotenuse. So the sine equals opposite over hypotenuse. So the ka, and so ka toa means cosine equals adjacent over hypotenuse. And then the toa would be tangent equals opposite over adjacent. So if you can memorize the acronym SOHCAHTOA, then you'll remember the ratios in the order that they go in.
SOHCA, TOA, will tell you where to go. You just gotta know about H, A, and O. Everybody looking at a glance at the box. The H, Y, P is sitting across. Theta, theta, is at the eta, eta. So on it, for the look, I don't mark it. Beside you ain't touching, it's the O. It's gotta be the ADJ. Get tricky with it.